Once, general antibiotic always saved the mouse by defeating bacteria. But now, the enemy has built resistant shields. Our generals of weapons fail. To win, they must find a new, smarter weapon. So, general antibiotic forges a powerful new alliance with heme. Heme possesses the advantages of high biocompatibility and desirable in vivo metabolic characteristics. Antibiotics can effectively display the chloride ion in heme and axially coordinate with the iron center, leading to self-assembly and the formation of antibiotic nanozyme. And the brilliance of this strategy doesn't stop there. This self-assembly process is incredibly versatile. The self-assembly strategy with the heme is applicable to a broad spectrum of antibiotics. Moreover, the antibiotic nanozymes exhibit prominent antibacterial efficacy against clinically drug-resistant strains. Antibiotic nanozyme possesses three remarkable capabilities: glutathione peroxidase activity, and ferroptosis inducers. Upon encountering bacterial biofilms, the antibiotic nanozyme infiltrates the biofilm matrix and depletes the intracellular antioxidant glutathione through its oxidase mimic activity. This disruption of the redox homeostasis critically compromises biofilm integrity and enhances bacterial susceptibility. When it targets free-floating bacteria, it can generate reactive oxygen species to efficiently damage the bacterial cell walls, allowing itself to penetrate the bacteria. Inside the bacteria, it can release antibiotics to exert its bactericidal effects. Additionally, the degradation of heme releases a substantial amount of free iron ions. This intracellular ion surge potently triggers ferroptosis, a unique form of iron-dependent programmed self-death in bacteria. And ultimately, the antibiotic nanozyme achieve a complete victory. And so, General Antibiotic, armed with his powerful gun, triumphed at last. He defeated the resistant bacteria and saved the mouse.